Look at Atalanta bucking in the traces. Ready to go. Let me go, Dad, let me go. Do you have a monitor 6 destination on your video switcher here in front of you? You do, I know you do. That's all right, I'll wait till we get down to, I get distracted easily. I missed it up there. I don't need it yet. The only one you really want up there, Jaden, is this one. The one on the far left, ROV pilotless. That one's shouldn't even be open. It's right there. It's just tacking my poor little pie.
Control deck. Atalanta is in the water.
Roger, roger. Hercules is dive, dive, dive. That's how we roll, Chris. Okay, now, on your video screen, you should have a, I don't have it. Why don't I have it? I have monitor, right? You should have monitor 6 there, one of the red buttons. Oh, wait, maybe it's monitor right, not monitor nav.
Do you have Atalanta lights on? It's real dark.
No, you can turn your Atalanta lights on now.
Yay, thank you.
Blast them all on. Why are you ladderling so hard, Herc? What's going on here? Yeah, you can turn thrusters on, but don't thrust. And you can enable them if you want.
This is an audio slate or dive H2072. UTC time is 19:19:50. Mark.
Is your sonar on? What's that? No. It's meso, or I think I've named it sonar, meso sonar. So I can, roger. Sorry if I ignore you at some moments. The main thing I'm watching is to make sure Herc is, the ROVs are stretched out, and I'm not way out of the box one way or the other. I get distracted easily, and I get like a loose tether. I get the tether all wrapped around.
Control,
like we
wind.
did the other day.
Go for control.
Understood.
I'll stop at 50 meters. Sending control.
Roger, we're ready.
Roger, control is ready.
We have us in control. Okay, let's go down at about 15 meters a minute.
Go.
Jade? About 15 meters a minute, just till I get comfortable here. Make sure everything's all good. I'll take that for a minute, actually. Why don't you do in that log, we'll do a 50-meter gauge check. So you can just write it in the book real quick. So that's the whole thing about the RMM. So
Yep.
res, motor, main. So they should basically all be 6.6. So the motor and the main are indeed, actually the motor's 8. So I got res, I'll call res 15, motor 8, main 6. And then TKT, which is term craft thrusters, 666 should be.
Copy.
I don't know if it is because I can't see it. It's out of focus. Yeah, 666. So I'm ignoring the change. I don't care.
Okay.
So like that fast. You know, res motor main, the top right one, ignore. And thrusters craft. That's not annoying at all. I'll let you play with that focus there.
Copy.
Before you write down gauges. I like to watch them on the way down. These are the critical ones here. So if we bleed out on the res or the main, we're dead, Jim, and the motor. We gotta bring them back up. The other ones I could, it's Robert's famous saying, I could give a rat's. I get an nav screen when you're ready, Chris. Checking is what we do. Okay, you ready for the winch now, or are you still writing over there?
I'm ready.
Are you ready? Ready?
Yep.
Are you sure you're ready?
Am I keeping it at 5?
It's supposed to be a 0. Plus or minus 5. Especially with this long tether. It's like, typically we'll want to keep Herc below Atalanta, so if you got a, I should say, minus nil plus 10. So you see on the left sonar, on your sonar up there?
Yep.
So if you keep Hercules below Atalanta a little, that's it. 30-some meters, almost 40 meters directly behind Atalanta. That's where we want it. So that's one way of knowing that it's in the right place. We're in the box, as it were, as I like to say. The other way of knowing, without looking at any of this mumbo jumbo, is your aft camera there on Atalanta. You should always see that light, especially when we're going down now. And then the other thing just to generally be aware of is the vessel's heading, Atalanta's heading, and Herc's heading, right? So in this case, Atalanta and the vessel should be roughly on the same heading. If you look up here and that's not happening, that means the boat's taking a holiday, which Nautilus has been known to do. Or Herc's taking a holiday, which it's been known to do. Usually Atalanta is rock steady. But you don't have your auto thrusters on now, so what happens if I'm not maintaining that a little bit of forward momentum with Hercules? I'll drift back, Atalanta will start turning its heading. The other thing I can do when I'm on holiday is I'll inadvertently have my auto heading off. Like I'll cycle it all the time here because it'll start doing this. One thruster's working really hard, one's not. So I can get away with having no auto heading on and just a little bit of forward way. But if I press the wrong button or get distracted or we lose a thruster or 100 other things that could go wrong, you won't see that tight tether and that light there. And then in the other camera you can see Herc's tether going up a little bit. If that's wrong, the tether will be coming out the side of that picture somewhere. No. let me get down past 500 meters, then you can, or at least 200. What's that? Roger. Yeah, I like to have a little bit more weight on the wire before we start maneuvering, Chris. If we start maneuvering now and the boat does something something crazy, then they'll run over the wire. Port and starboard PSI. Huh? No, that's old stuff, but you could get it. Yeah, that needs to be updated. Historically, that was the Valpak PSI, but they now have pressure reducing valves, so I can put them anywhere we want. So some other things we should sort out sooner than later. I should have craft telemetry. Which I do, so I like to turn on the craft arm. It's my firm belief that if you have hydraulics energized, there's high pressure in the arm and seawater stays out a little bit longer. And I'll usually leave it hot the whole dive, which is different between the different operators up here, but I'm the person that has to work on it and fix it. And then if we want, we can give the, we basically now we'll do, ooh, that's hot. We'll do the same thing we did on pre-dives, but this one is the real deal. So we want to make sure everything's working and good before we spend an hour or two heading down. It would be tragic to sit here for 2 hours with the winch running and only to recover because we didn't check some function. What's that? Was that, sorry, was that for me? I don't know. It is still in development. I haven't got the green light to have it up here for a dive yet. Sometimes, you know, it's easier to get forgiveness than permission, but if there was an issue, we'll have it up here soon. We're getting close. Jake was up half of, way past his normal watch hours. Working on that thing. I'm not sure how far he, not sure where he got to. But I'm really ready for it. This hunting around for buttons in here is painful. I'm going to switch cameras over to the jars and we'll have a look there and make sure. Sometimes that thing can get a, it can get a airlock. So if I would have had my act together, I probably would have ran it at 50. I see the one thing we should check and get after the scientists a little to clean those jars a little better.
All right, Dan, I have a question about that because I've been cleaning the jars, and the jars are clean, but the sediment is up in the mesh,
Right.
and so I guess we should hose that down. I wanted to ask you about that because the mesh has been pretty kind of gross looking when I putting the jars back on.
Yeah, you're gonna take the mesh out and clean it out.
Well, someone's gonna have to show me how to do that.
You go like this.
Okay, there's no secret?
No.
Okay.
The mesh is just tie wrapped around the little cylinder there.
Yeah.
Yeah. Sorry, I should have shown you that. It's super easy. Usually, when look at all that stuff coming out of the hose. Usually,
that was not just the mesh. There's more in the tube then.
Yeah. So usually when scientists get the jars down, their sample, they take the mesh. So as soon as they unscrew the jar and pull it down, they slide the mesh off into the jar right then, and they take the whole mess in. So a lot of scientists are micro, DNA. We have different size meshes that we put in there, so the entire sample is on the mesh. Yeah, and yeah, you're more macro, obviously.
Yep.
But the corals, their associates all wind up in the mesh, and then you get cross contamination, and then also we don't want to be dragging animals from site to site. So if you want, we can set up some spare meshes, so you just
we should be able to clean that one on the front. I just misunderstood what the procedure was.
Yeah, sorry. I'll have to I'll ask May to put that in our shiny document. Okay. What's going on the winch there? No, I need to I'm ready to light the afterburners here. So we should be able to pick up the speed a little bit here. Yeah, I gotta get to the seabed. Let's do, sorry, Jade. You can bring up your utility page. We'll put in, what is the depth, Chris?
All right, Ali.
Sorry,
and
stand by.
Good morning.
Sorry, what is it? 2,400. So you bring up your, go to your utility page, enter bottom depth, and hit enter. Or hit clear, and then enter 2,400. And then you see the vertical velocity there. So Herc's vertical velocity right now is painfully slow. Not sure what's going on here.
So match that.
Yeah, match that. We can drop out of SPL if you guys want to do your thing back there. Sorry. I will do that.
All right, thank you.
Oh, we're going to be technical mumbo jumbo up here for a while.
Ali, and good morning from Palau. It is currently 4:36 a.m. on November 3 on a Sunday, and ROVs are currently descending down. to survey an unnamed seamount which was mapped for the first time by EV Nautilus today. This seamount summits at a depth of 1,500 meters and is located roughly 70 nautical miles east of Babaldaw Island and inside the Palau National Marine Sanctuary. Before we start explaining a little bit more about this dive, can I ask the back row to do some introductions?
Sulong L, thanks for the introducing the dive, and Ali, everyone. My name is Brian Kennedy. I'm the chief scientist at the Ocean Discovery League and the 4 to 8 watch lead in here. I'm a deep sea benthic ecologist, looking generally at the patterns of biodiversity of benthic communities on seamounts across the Pacific, and I'm really happy to be here.
Ali, everyone. My name is Harold Carlson. I'm a PhD student at the University of Hawaii at Manoa. And I'm also a benthic ecologist. I'm interested in deep sea habitats on the seafloor, how they relate to mainly fishes, but sort of the entire community. And very excited to see what we find on this seamount today.
Okay, Ali, and hello everyone. Good morning. Miltutal Mergidarogui. I am Ayla, and I'll be the data logger for the next few hours, the 4 to 8 watch. I'm a Marine Lakes Research Assistant over at the Coral Reef Research Foundation, and we work a lot in the marine lakes of Palau, which are isolated bodies of seawater, some of which hold jellyfish, the golden jellyfishes. And yeah, I'm excited for this dive as well. Can't wait to see what's in store. Yeah.
And we have a special guest here in the back row. If you could introduce yourself, please.
Ali, good morning. Can you hear me okay?
Yes.
I'm Jeremy Wyrick. I am director of NOAA's Office of Ocean Exploration. We're the primary sponsor for this mission, and it's a privilege to be out here and sailing with everybody here on EV Nautilus, as well as communicating with our friends in Palau. So thanks for letting me join tonight.
Thank you. And last for me, my name is Elle, and I am the Science Communications Fellow on this one of the Science Communications Fellow on this expedition. Very excited to be here and see what is down here in this new area. Brian, can you explain a little bit about this dive and why was this chosen as a site?
Sure. So we're diving a previously unmapped seamount, a little ways offshore, I forget how far, 50 miles or so, due east of kind of the main aggregation of Palau Islands. So we are now, the last couple dives, we've all been on the west side of the trench complex, and now we're on the east side. So now we're on the Caroline microplate, part of the larger Pacific plate, that's being subducted under the Eurasian plate complex to our west. So this seamount might be really interesting geologically because we're right at the base of the Yap Trench and just on the east side of the Palau Trench. So we're in an area of really complex geology. And this is kind of a seamount. There's several big seamounts here rising from a depth of almost 6,000 or 7,000 meters, depending on which trench you're measuring from, up to a summit depth of about 1,500 meters. And we're going to be exploring the kind of south, a rift arm coming off the south side of it. So we're going to find the seafloor about 2,400 meters and follow it up till we get kind of nearish the top. We're not going to actually make the summit itself because this is, I wouldn't call this quite a guyot, but it's kind of got a big, broad, flat top on it. So we're going to kind of get close to the summit depth while staying on the kind of south flank. Hopefully this seamount's kind of out in the currents, and this ridge complex and this depths and slope values we're looking at on the seamount should be really conducive for a lot of deep sea coral. So I'm quite excited about this dive.
And how would one name a summit? a seamount. This is a question from a viewer who's interested.
Yeah, so there's a couple different groups that maintain a national or international cadastre of marine names, and so you can submit names that. It's a little bit of an intensive process of doing geological workup, doing academic research about what else the names has been considered, and then you submit a pretty hefty document to that group, and they will review your application and approve the name.
Very interesting. So, there's another question. As we were descending, one viewer said that I see fish coming across the screen, and they were wondering, are they minnows or full-size fish, or may some more be in between?
Yeah, so these, I can't tell exactly what kind of fish they are, but my guess is that these are adult fish. They're small fish, potentially vertical migrators coming up from deeper waters towards shallower waters to feed at night. And it looks like they may be attracted by the ROV lights. We definitely see this with all of the squids that show up when we're in the surface waters heading down at night or coming up after dark. Things tend to get attracted to our super bright ROV lights. So it's fun to watch them sort of swim around in our various cameras that we have.
Thank you for that. So to our viewers that are listening and tuning in, please send in your questions as we descend down. And how long would it take to reach the bottom?
I have to do math.
Okay. But yes, this dive is expected to be 16 hours, and the max depth is 2,400 meters.
Like Brian was saying earlier, this seamount is pretty close to the Yap and Palau Trench Complex, and that's geologically interesting because we are sort of in the oldest region of the Pacific oceanic tectonic plate. So the seafloor that we're about to look at originated over on the East Pacific Rise many millions of years ago and made its way all the way over here and represents some of the oldest ocean crust in the world.
Or it could be hotspot volcanism. The crust does. The oceanic crust, absolutely. But when the seamount could have been a hotspot volcanism generated somewhere in between there as well.
Yes, so we won't really know until we get a rock sample.
And then get it back on shore and do a whole bunch of radiometric dating and stuff like that. So we won't know today. Back to the earlier question, we got about an hour and hour and 20 minutes probably at the bottom.
Would that involve cutting up the rocks?
Yep. So, you know, all the rocks at this depth are going to be manganese encrusted, and so you got to cut open the rock to see the actual underlying volcanic rock, and then in order to do some kind of radiometric dating, I think usually they use a uranium series for this chemistry of rock and kind of expected age, and that involves I don't know the actual process of it, I've never done it, but it definitely involves like grinding up the rock and making a powder and then testing for the different isotopes.
There's a mass spectrometer involved,
yeah,
I imagine.
All right, we got a question from a viewer from the UK. Does the presence of the very deep trench complex in the area affect the ecology of the seamounts compared with areas that have less extreme topographic variation?
As a general rule, yes. Complex geology and complex bathymetry often means more interesting and more diverse ecological communities. It's not a definitive one-for-one. There's a lot of other water chemistry, water motion, dissolved oxygen concentrations that all play into that too. But as a general rule, places that have more interesting bathymetry and topography, I find have more interesting biology as well.
That's an interesting question, though, whether or not a trench could be a biogeographic boundary between two seamounts. And my thinking is probably not if most of the animals we're seeing are dispersing through the water with pelagic larvae, but depending on how the trench affects the ocean currents and the physical oceanography of the region, I don't know. That could be interesting.
For broadcast spawners, I totally agree. But some of the corals and sponges, or some of the corals we see down here, are actually brooders, and so they have a lot lower larval dispersal range. So, but these trenches are relatively narrow. So, like it's less than 50 miles to jump from where we are now over to Palau, and so I don't think the Palau trench is going to serve that much.
We have a question for the front row. Are they free to answer a question? We have a tech question asking about how much tension is on the ROV line and what is the line rate max tension.
Yeah, hey, I'll jump in there for you.
All right.
The current tension is about 4,000 pounds. What is the max rated for the 6.8, Dan?
Our safe working load's around 15,000 pounds.
Thank you.
The cable, the braking strength on the cable is like twice that, like up at 35,000 pounds. But yeah, we can and have taken it right up to 15,000 pounds. We did on the midway dives, on the carrier dives last year. We had Atlanta all the way down, close to her rated depth, 5,000 and change. It's the snap loads that we really worry about. Is the Nautilus pitches up and down on that cable. Coming loaded and unloaded, it can be, the snap loads can be exceed our safe working load. So we really keep a close eye on that when we're down deep, and especially if we have any weather. Many times we've had to haul up a little bit to reduce the load on the wire.
Another question from a viewer. Does the ROV lights disrupt the sea creatures who usually don't see much light in their lives?
Totally. Blinds them for like centuries, decades at least. I know when I look at Herc lights, I can't see anything for at least 5 minutes. I wind up walking into bulkheads and walls. And
yeah, so that a lot of the deep sea creatures are optimized to see bioluminescence, which can be different frequencies, and so the lights may not appear as intense to them because of whatever frequency lights they're optimized for. But the animals that kind of have a full range of visible light spectrum, it's very possible that the light bleaches out, or the light bleaches the photopigments in their eyes. It's a temporary thing; it'll come back probably in a matter of minutes to day, depending
Probably
on
less than centuries.
Yeah,
hopefully.
probably a lot less than centuries or years.
that's what that's kind of been my experience every time I inadvertently look at Hercules.
Well, Dan, you must be much older than you look then. But yeah, you'll certainly see some of the fish will react to the lights. The snaphobranchids often are the most obvious in their displeasure, which could be part of the lights, could be part of just sensing the very large, moderately loud submersible coming at them. Some of the other swimming fish are more likely to exhibit some signs of distress. I haven't really seen the invertebrates respond much to the light that I can tell.
Yeah, so while it may temporarily blind some animals, it's of course the only way we can see what's down there, because we are adapted to the sunlit world, and we have to bring these big lights down to actually visualize the environment.
Yeah.
So when we actually take these deep sea images and videos, it's sort of interesting because it's everything we see is not as it appears in nature, because in reality it's all dark, lit by a little bit of bioluminescence. So these brightly lit cinematic videos and pictures are all sort of a creation of us.
Do you think some of the animals see kind of like Predator does?
Sorry, Dan, can you move your microphone a little closer to your mouth?
Do you think some of the animals see more like Predator does? I'm referring to a movie.
An infrared?
Yeah,
Probably not.
or some other spectrum that we don't see in, like, you know, dogs.
Yeah, there definitely are other
animals
spectrum.
Yeah.
Some of the creatures down here are optimized for different spectrums. I doubt infrared. Infrared doesn't travel real far in water,
Right.
but more probably shifted towards the ultraviolet spectrum. But yeah, definitely there are something. I mean, mantis shrimp or stomatopods in shallow water, the kind of everyone's classic example of having, I forget how many different color receptors they have, but it's a lot. Most humans and vertebrates have 3, and they have a bunch. I think it's like more than 10, right?
Wow.
Yeah, those are the stomatopods. Those are the mantis shrimp. Super colorful shrimp with the ultra-fast punching fists.
I've seen some photography images, like full spectrum photography, where they're taking pictures in spectrums that we can't see, and then somehow coloring it. So
yeah, that's actually
our
an
mind can
area
process it.
I'm really interested in and would like to see more tech development is using hyperspectral imagery underwater, because there are pigments, there are things that can be imaged that are outside the human visual range that could be used for helping understand and distinguish some of these different animals we see down here. Like some of these things, especially members of the family Paramericidae and the Acanthogorgids, are really, really hard to tell apart just visually. You have to look at them in a microscope in a lab and stuff like that. And I've often wondered that if we had a wider spectra available to the cameras, if we could help distinguish some of those hard to tell apart taxonomies or taxons. So that's something there's a few people doing research with deep sea hyperspectral imaging. It's something I'm pretty interested to see how it comes along. We think about the way NASA and the space community uses hyperspectral imagery for Earth monitoring, like the PACE satellite system that just came online in the last year is going to really revolutionize our ability to monitor the ocean for plankton blooms and stuff, because there's so many different spectra that are available to that instrument. They'll be able to probably get species level identifications of different plankton blooms just based on the unique spectra they produce. And I've always wondered if we could use a similar kind of thing in the deep sea to help do automated annotation and species detection.
We did actually. I think it was, I can't remember, last year or year before, we had the Raman laser on here, and that was just out of this world, literally.
Yeah, I was one of the cruises I was at here with you.
Oh, you were.
Yep.
Yeah, you were. So how did sorry, I forget. That's been 2 years ago now, Brian?
A year and a half, yeah. It was.
Yeah. What was the final analysis, crunching that data after the cruise?
I haven't seen a lot of it I haven't seen any of it from the stuff we were looking at the animals. I know they got a couple fluorescent peaks off a few of the echinoderms and stuff like that.
Right.
That was they had a kind of a broader range of sensitivities, but they were doing a little bit different. They were actually using a laser to stimulate fluorescence. So it was a little bit it was more of an active sensor than what I was just talking about, and just a passive looking at what the reflection was. But they were pretty happy with the performance of the sensor. That was definitely a tech test. They weren't collecting data specifically for any kind of specific analysis. They were trying to make sure the equipment worked and that the principle stood, and they definitely were seeing variation across substrates and different mineral types with the sensor. But what they have done since then, I don't know.
That would be interesting to know, because they were teasing us. Like, we literally had to put the thing on the ROV with a crane, and you know, kind of like the computers of the old days took up an entire room or a warehouse, and now I have one in my pocket. So they were teasing us that, you know, that would soon be down to more camera size, something manageable that we could put on the vehicles easier, and put on smaller vehicles as well. And I haven't chased it up.
Yeah, their goal was definitely to get it on some kind of smallish AUV, I think.
But isn't that same technology used like on the Mars rover and
yeah, I believe so.
So they had NASA stickers all over the thing. There's still NASA stickers floating around on the boat. You are anxious to move that boat 100 meters. Yeah, good for the move, Chris.
Hey, Dan,
you got
we have a
that magic
question
5,000.
I
Yeah.
have a question about ROV Herc. What is the difference between the arms on Hercules?
The main difference between the arms is one is a spatially correspondent 7-function bilateral manipulator, and the other one is a rate arm. So that mouthful of technical jargon is basically one is smart and one is not. Or
Okay.
the starboard arm has several. It's closed loop control, so it has active valves and feedback, position feedback in it. Sorry, I'm trying not to go techno jargon here. And the other one is just has what a lot of people call hydraulic rams, but the proper term is a hydraulic actuator. And it is just controlled by a valve and a valve pack, so it doesn't know where it is in space, and it's just actuated by some buttons, or what we are, mostly Jake, but also myself, actively working on controlling that would be more like controlling the crane on Nautilus's deck, or an excavator, or a backhoe, or something like that. So you pull levers and the arm moves. And we're all about tactile control up here, so we're literally emulating excavator controls for that manipulator. Currently, we press buttons on a screen, which is very boring. You know, I don't know. Some people like to do the keyboard and mouse for their video games. Some people like, you know, just PS4 or Xbox or something, and some people have these elaborate, you know, simulators set up. But for us, the tactile control is a little more helpful than, you know, pressing a mouse button. The starboard arm has a mini controller up here sitting next to me, and the spatially correspondent part is, so when I pick that thing up and turn it on, wherever I move the mini controller, which is a kinematic replica of the manipulator on Hercules, it moves in real time. So the spatially correspondent part. So and because it's moving live like that, it's much more the dexterity and speed of operation is faster, but it's also a bit more of a challenge to operate. Like I could easily poke my eye out on, which happens to be the Zeus camera.
And which one is the starboard side?
The starboard side is, are you referring to which? The starboard side is
right?
Yeah.
Okay, and then the left side is
Port.
okay.
Yeah, sorry. I remember that by port red wine for some reason. Red right return. There's all kinds of strange sayings.
Yeah, that doesn't work in this part of the world, though.
No.
We're in ILA B or A.
Really?
Where the buoys are flipped.
I would crash into the rocks then.
Yeah.
That would be bad. I do that all the time anyways. That's kind of my... it's really weird. You'll hear the ROV say, we lateral left or right, but we turn to starboard or turn to port. I'm not sure why we say that, but I think just to differentiate whether we're using the horizontal thrusters to go opposing like skid steer, or whether we're using lateral thrusters to go sideways like a bow thruster on a boat. Roger that. I want to see the seabed from the eye of God.
So just an update for our viewers. We are now at the depths of 870 meters and going down to 2,400 meters. Yeah. Thank you, Dan. Brian.
At the lightning speed of 33 meters a minute.
Yeah, you guys are making good speed.
Yeah, we are. Jaden's breaking the speed limit over there. She's in the yellow.
So we've been seeing some jellyfish as we descend. Is that, do you guys know what type of jellyfish?
We've seen a couple siphonophores. I've seen a couple salps. You know, going at this speed, making a good identification is just about impossible. But there's definitely a lot of gelatinous organisms in the water. We're seeing lots of flying fish and all those little small fish we saw in the surface waters at deployment are a good sign that this area is relatively productive, which is another pretty good indicator we might see a fair amount of diverse benthic life.
Oh yeah. Based on what's up above, you're predicting what's down below?
More or less. I mean, the primary food source for the types of communities we're looking at on this dive are all surface derived. So it's phytoplankton in the surface, fixed carbon using the energy of the sun, and then due to a whole bunch of different complex mechanisms, that food gets exported out of the surface waters into the deep sea, which feeds the benthic communities. So if you've got more food production in the shallow waters, you've got more food available in the deep waters.
That makes sense.
So what is everybody hoping to see when we get down there?
Fields of coral as far as the vehicle can see.
Yes, that would be amazing.
High density. I'm hoping for cliffs and overhangs and big giant boulders that we can pirouette around. Discover like really awesome stuff on one side. The porch is retracted. But the camera's out. Are you seeing a shadow? Oh, no. Let me double check.
And how much time till we reach the bottom?
Stand by, let me consult the AI. Time to bottom, 44 minutes, 53 seconds.
All right, thank you.
You know what, that might be one of the lights, Chris.
There's a question from a viewer. Is the research on migratory birds still happening on this trip as well?
No, I don't think we don't have a bird observer on this leg like they did last leg.
It wouldn't be that light there, would it? That's the transmitter, right? That's not where you're seeing it?
I actually saw a small bird a couple days ago, early in the morning, and I've been sending pictures of the birds I've seen so far to one of my colleagues from Palau Conservation Society, who's a bird expert. So one of the migratory birds I saw, and she told me it's a gray streaked flycatcher, and she said it's migratory season right now,
What's
so we
it look
might
like
see a
now?
lot of cool birds
That's the porch out.
I've also seen a cattle egret, as well as brown boobies. Maybe a masked booby, I'm not too sure. My
What's
eyes are
that?
not that great when I see them
That's
flying
porch all
from
the
a
way
bit
out
far
there.
from the boat. But yeah, we've seen a few birds.
And if I go in, oh, you know what? We have it pegged out one further because the actuator is bent. So normally have vac one, but the actuator is catching on a redundant cross member that I've been threatening to cut out, and everyone's freaking out because they're going to cut it out. Oh, it's structural. You tell me it's interfering, it's out of there. I get the sawzall when this thing comes on deck. Roger that, it's coming out. I like getting the sawzall out on her. It's great when you can.
We actually got a few viewers shouting out to Dan, and they love the Descent with Dan
that's
show.
Unfortunate. Good to know. So you want to make a note in the red book? You already. Oh, I'll let you off the hook here. So you can run this until we get Doppler beams or 100 meters off the seabed. This is our, and you'll get a kick out of this. Under no circumstances shall the spring center function of a control joystick be defeated, mechanically held, tied, or restrained in the off-center position.
Apparently the Descent with Dan show is the best drive time radio
Just so
chat
you know.
ever.
Dan, they're complimenting on you on the SBL.
Oh.
Missing it.
Good distraction, Jaden. Good distraction.
So question here, what is the coolest thing you've seen on Descent?
Ever? The coolest thing I've ever seen on Descent was it was a couple years ago. I was just north of Howland Island, about 1,000 miles-ish east of here, and we had a whale shark swim across right in front of the vehicle about 770 meters down.
Oh my gosh.
No way.
Wow. We have a question here. Have you ever seen prehistoric fish live or otherwise? What is a prehistoric fish?
It depends on your definition of prehistoric. Obviously, if we're seeing them alive, they're not prehistoric anymore. But yeah, we see fish and mainly invertebrates in the deep sea that are have been little change for millions and millions of years.
Yeah, like one thing that we see pretty frequently is crinoids, including stalked crinoids, which is a type of animal that is best known by the public from the fossil record. Like, one of my friends was watching the live stream the other day and didn't know that crinoids were still alive. They thought they were just a prehistoric animal. So there are things in the deep sea like that that are sort of, we discovered them first in the fossil record, and then once we got the technology to explore, we find that they're still hanging around.
Is the Nautilus a really old species?
Yep, Nautiluses are pretty old. We're not going to see them on this dive. We're too deep, but that is actually on one of my bucket list items for this cruise. Is if we get into some shallower depths, is to see a Nautilus.
Palau has its own species of Nautilus, the Nautilus bellowensis. Is that how you pronounce
Bellowensis.
it? Bellowensis?
Yeah. And Nautilus in Palauan is Kadarm.
Kalarm?
Kadarm. So
Cool.
Kedarm.
Cardlarm.
The K is kind of like a G sound a little bit, but it's still K. Kadarm.
Okay. Kalarm.
What depth range are they usually found in?
Ooh. Nautilus depth range.
Harold will look it up to be sure, but it's kind of mesophotic generally, below scuba diving depths, and little bit shallower than a lot of the work we're doing here. I think it's 100 to like 300 meters or something.
So the deepest diving species is around 700 meters. I'm curious about Nautilus bellowensis, though. Let's see. Mm. 150 to 300 meters, according to Wikipedia.
For bellowensis?
Yes.
Oh, cool.
We got a question here. Have you ever found fossils in rock samples taken from these from seamounts?
Short answer is yes. I've certainly seen fossils in the rock. I don't remember if we collected it or not on a cruise I was on, but I know Nautilus has brought up fossils a couple times, and they were in rocks. And then I've been on cruises where we found fossilized beaked whale beaks, and have brought the lower and upper jawbones of fossilized beaked whales before.
We've actually collected some, I guess you could call them fossilized sponges. Something we've seen pretty frequently is these dead sponges littering the seafloor that have been encrusted with manganese, which is also covering all of the rocks and hard substrate. So these dead sponges get preserved, and we can have a look at them and try and figure out what species they are. And sometimes they're a species that we don't recognize from the living community. So there's a bunch of dead sponges that are a different type of sponge than the living ones. So that represents a potential shift in the community, or a shift in environmental conditions, or new recruitment events. It's very interesting to see.
Yeah, they're doing a pretty good job.
We got an interesting question here. Do you see the effects of climate change in the depths that you go down to?
So it's interesting when you think about the monitoring climate change in the deep sea. We know so little about the deep sea because it's so underexplored. We don't have a lot of long-term baselines to compare to. So in some places that you do have long-term monitoring, there's definitely are seeing changes in the water chemistry and stuff like that. But for the most part, it's really hard to, like, from a benthic ecologist point of view, to say this is change over time is due to climate change because of how little information and how long we have monitoring on it.
Yeah, one example I can think of is I recently saw a presentation by a researcher in Canada, Cherise Dupre, and she's gathered a lot of repeat ROV dives from sort of the waters off of British Columbia, and they're seeing an expansion of their oxygen minimum zone. And this is one of the consequences of ocean warming. It's a bit complicated to explain, but basically levels of oxygen at certain depths are decreasing. and they've gone back to certain sites that used to be just completely covered in glass sponges, and they've gone back after the OMZ, the oxygen minimum zone, has expanded to that particular depth and seen high mortality rates among the sponges there. So these time series studies in deep sea research are hard to come by, but whenever we do them, we find out new and interesting and sometimes sad things like that.
Yeah, and a lot of the cabled regional arrays and stuff like that that are getting established around the world in deep sea are really going to help with our understanding of that, of providing long-term ecological monitoring where we can start to assess change. And thinking more about the oxygen minimum zones, like that's one of the biggest impacts that, as Harold notes, we're already beginning to see from climate change. Is they're expected to expand dramatically under most warming scenarios. We're going to go, the areas of the ocean that are quote-unquote hypoxic are going to increase dramatically.
What are some other stresses that deep sea corals face?
So they can, there is predation, or we call it coralivery. I haven't seen any yet, but there are on this expedition, but there are many things that will eat corals in the deep sea. Sedimentation can be a real problem. So if you've got extra sediment in the water, disturbed from area of riverine input, wherever it comes from, having lots of non-food particles settling out of the water can be very bad. The sclerotinians that use calcium carbonate or aragonite specifically to make skeletons can be heavily affected by ocean acidification. The deep sea is generally more acidic than the shallow water already, and so it's hard for sclerotinians to make skeletons the deeper you go. And if you start making the world more, or the oceans more acidic, that's going to force them into shallower and shallower depths. What am I missing, Harold?
Well, there's other human activities that threaten corals as well, like bottom trawl fisheries can drag across the seafloor and knock down corals. And we're also potentially going to see a rise in deep sea mining in the future. That's another activity that has potential to disturb the seafloor community, in addition to sort of just knocking things over, creating a lot of sedimentation in the water, and that can also negatively affect corals. But that's not something that's been widely implemented yet, but we may see it more in the future.
Yeah, and then other things like changes in this that can cause changes in primary productivity in the surface waters for a whole host of reasons can affect it, because that's the food source for these for deep sea coral communities. And then had another thought in my brain. I lost it. What was the other reason? And current ocean circulation. So a lot of, the deep sea life is very tied to the water quality, the water masses back to the oxygen and whatnot. But other things as well, moving food, stirring up sediment in a good way, and moving sediment. And if we start seeing large-scale major climate changes, there's a lot of indications that some of the overturning circulation, especially in the Atlantic and the Antarctic, might be reduced, which would have global ramifications in the deep sea as well.
Are there any plans to add a pH sensor to Hercules based on the acidification?
Not that I'm aware of. pH sensors are actually frustratingly hard to calibrate and maintain, and they require a lot of care and feeding, as some people would say, to keep them at a high level of accuracy.
got another question from a viewer. Does the deep sea ever have issues with invasive species?
Absolutely. Again, it's one of those things that we haven't done a whole lot of. We're still just data deficient in the deep sea, so we don't have a lot of examples, but there certainly have been a few examples or documented of new species showing up and moving around. Some of that's just natural ecology, in that species do move and change and find new places to live. But there have been one or two documented examples of research submarines actually moving animals from one location to another.
Yeah, invasive species in the deep sea, that's actually not something I've ever really thought of. We think of it a lot in shallow water from the movement of ships, bilge water, people, things like that, but there's so little contact between human technology and the deep sea floor that you'd think it wouldn't be that much of a problem, but we do actually interact with the deep sea floor in many ways, not just through submersibles, but through all of the various instruments and industrial technologies that we have all over the world.
And some deep sea organisms, larval phases come up pretty shallow too, where they could theoretically be sucked into ballast water and moved a great distance before being discharged.
Huh.
So I'm wondering if like the submarines have regulations to, I don't know, like how ships will have to clean their ballast water when they're moving.
Yeah, oh no, we absolutely, wash down the vehicle every time. Dan and I were just talking about how we were missing a spot on Hercules last two dives that we need to do a better job of cleaning just to prevent that. And so, yeah, we're aware of it and definitely try and make sure the vehicles get cleaned really thoroughly in between dives to prevent us from doing that.
I got a question for the back row. So is this site similar or different to the previous dives we've done during this expedition?
It's similar in that it's a tall seamount that gets in the water depth of about 1,500 meter summit with kind of similar slopes on the side. But the geology and some of the water flow might be pretty different here, that we've moved away from being north of Palau as part of like the Palau-Crucio Ridge, and now we've jumped over onto the Caroline Plate, and so the oceanography here might be a little bit different. Sorry, it's the Palau-Kaishushu Ridge. I misspoke. Crucio is the current.
We got a question here. Are the sea cucumbers and other creatures that are sampled able to withstand the change in pressure when brought up for research?
It depends. So a lot of them a lot of these don't have air pockets or things in them, so it's less a function of the pressure change in terms of like looking at them, and it's often more temperature or just being handled, moved, whatever. So of the 4 sea cucumbers we collected yesterday, 3 came up in pretty good shape, and 1 was very damaged by the transit up. And I can't tell you exactly for sure if it was being slurped up in the slurp gun, or if it was temperature change, or if it was pressure change that affected it. But the deep sea fish and stuff like that down here don't have swim bladders in the same way that like shallow water fish do, so you don't get the bariotrauma associated with them you do when like you catch a deep rockfish or a deep snapper or something.
Okay, so there was 1 sea cucumber that came up and I was holding it and it was kind of pulsating. Does that mean it was still alive, or is it?
We were debating that.
Okay.
It is definitely possible that it was still alive. We routinely get animals in the bio boxes and the slurp samples that are still alive. The quivering, pulsing like that, I'm not entirely sure what that was.
Oh, okay. But that was pretty cool to feel.
So if you're watching the live feed, we're just doing a little manipulator testing and practice for the front row. Our ROV intern, Jaden, is getting their first chance at working underwater with the manipulator arm. This is actually a really difficult task, is running the manipulator arms, because you don't have stereo vision. So you have a single point camera, so depth of field is really hard. It's something we take for granted, having stereo vision. Your eyes kind of naturally get a sense of depth of field. But when you're working with cameras like this, you don't get that. So you have to use multiple cameras from different perspectives to understand where the arm is in space in all 3 dimensions. So they've got the main HD, which is what you're seeing, sent ashore. And then there's multiple situational cameras on the vehicle from different angles that they've got put up on the control room wall to help get a better sense of three-dimensional space using a two-dimensional camera.
Yeah, you can try this at home, and this is something I overheard Dan say. If you just close one eye and try and pick something up with your thumb and index finger, you'll notice it's quite a bit harder.
You almost need to close. Your body has a little bit of a memory of depth of field. You kind of have to close both eyes, move yourself a little bit, and then open one eye to really get the full effect. I have gotten to play with the arm once or twice, and it is shockingly hard to use it.
Yeah, our pilots make it look so easy. And this is not a problem that you would necessarily have if you were a submersible pilot, because you can just look out the window and use your own depth perception to move the manipulator arm around. Still difficult, I imagine, but you're there.
How tall is this seamount?
From the base of the trench, it's quite tall. We were seeing 6,000 plus meters on the sonar as we were approaching it, and then I think not too far to our east, the op trench gets down to almost 8,000 meters. So I'm sure we could quibble on exactly where this seamount starts and stops, but it's it's 4,500 meters tall from the deepest part of the surrounding waters, at least.
Wow. So when it says the seamount summits at a depth of 1,500 meters, is that the top?
That's the top, but it's measured from the surface of the water. So the shoalest point for the term, but the shallowest point on the seamount is 1,500 meters below the surface.
Okay.
And then just nearby, it gets down to over 6,000 meters water depth.
Here's an interesting question. Can the ROV hands shake hands?
Well, that's basically what they're doing.
What's the difference between the two grabbers?
On the different arms?
Yeah. Is there a difference or a purpose for each arm?
So we're gonna reconfigure the cameras here so you can get a better sense of what's going on in the control room with Jaden practicing with the arm for the first time.
The arm on the right is the one that we typically use to sample. So it has shears on one side of it so that we can cut through a coral branch. And it has these sort of plastic tubes in the middle so we can hold on to something gently. And that arm is the one with the super fine motor controls and feedback. So that's really the main arm that we use, and then the one on the left is more of a coarse activity.
Camera ready? Let's go.
Yeah, so if you're watching at home, if you go to the quad feed on satellite feed 3, you can see how Jaden is manipulating the master arm here in the control room.
The mini controller.
The mini controller.
Titanium versus stainless steel. Both of them unbreakable. Jaden is this is their second time operating the craft, and they are just a natural. So we're going to hopefully have an opportunity to pick up some rocks or do some samples. Are we going to get some rocks on this one?
Yes.
Brian?
Yep. We definitely want rocks.
Yeah.
Well, when we hit the bottom or don't hit the bottom, get to the bottom.
I can hit the bottom.
Yeah, don't hit it very hard. Might hurt the seamount.
It would.
We'll want a Niskin and a rock pretty quickly.
Roger. How do you feel about that, Jaden? You ready to pick up a rock? Are you bored with what you're doing there yet?
You could try rocks, I guess.
I think you could. I think you're ready for rocks. Rocks can be super easy or just frustratingly challenging, depending on what the scientists ask you to pick up. But that would be a good time. So when the boat's static and we're not in a we're not time constrained because Atlanta's trying to run us over.
Yeah, the rocks don't generally try and escape.
Oh, they do actually.
I suppose, in a way.
And they greatly resist coming sometimes.
Yes, they do. Especially with all the encrusted rocks, they look like, it looks like one sitting there, but it's like welded to the seabed. And we hunt for hours trying to get one that we can actually pick up, depending on the bathymetry. And the geologists can be quite picky. They want to make sure that the rock is, not rolled down the hill or been carried in by a glacier or something. They want it. They all look like rocks to me. I can't tell them apart, but.
Yeah, I don't think I've gotten a rock yet that a geologist hasn't told me that it could have been better rock.
Yeah, totally. But one thing is easy. Geologists are usually greedy, so like they're like a kid in a candy store. Do you want the small slice or the big slice? So we get these giant rocks that barely fit in the sample box, and of course the biologists don't like that because it takes up all the room for samples. It's quite entertaining for me up here, causing chaos between the scientists in the back row. That wrist is another one that's tricky. So you see on the side you're looking at now has the two urethane hoses that you can see. And then the other side has the two blades that we used to snip corals with. But the proportion of it, the rocker is quite sensitive, so I can go really fast if I want, or I find it the most challenging is to move the arm slow and steady. It'll move really fast. The servo valves in there are similar to servo valve that's used for an airplane, either on an elevator. That's where those, the original manipulator that's, in fact, we were buying military surplus Polaris missile flight control systems, the actuator and the servo valve, so it was just lightning quick, and the hardest thing was to get it to behave in a kind of a robotic fashion. You see a lot of operators are very jerky in the arm. It's really fast, which makes everyone in the room really nervous because we're around, 1,000-year-old coral and 6-digit jewelry on the front of the ROV.
Dan, the delta's getting pretty high.
Yeah, it is. And I say I was going to deal with the winch. Oh, I know what's happening. What's happening is I'm a horrible co-pilot. That's funny, usually it goes the other way, because Hercules is only 20 horsepower, and you're using about 5 of it to just turn that craft arm on. Thank you for letting me know. Try and correct.
We're starting to see the bottom 200 meters.
Roger. Don't see any beams yet, or no hints on the sonar. Which
not on that sonar.
Which way's uphill? Oh, you're seeing it in orbit.
Yeah.
Which way's uphill, Chris? Northeast, south, or west?
Northwest will be the direction of travel, uphill.
Bonus. Herc's already northwest of Atalanta. Did you plan it that way, Chris?
Yeah.
Thank you.
That's kind of a funny. We're coming in right on top of a ridge or something.
Oh, yeah.
That's the plan.
I like it. Ah, Jaden's going for the hidden jaw. Nice.
So Dan, what's the status of the cinema cam? Are we on? Are we trying time delay photos today, or are we still working on focus?
That is above my pay grade.
Okay.
That would be up to the.
Does Mike need to just have an input on that, or?
I don't know. That's you have to ask Daniel.
Okay.
I know they've been chit-chatting about.
Yeah, Daniel. We talked to Daniel yesterday, and he said that the next part of the testing was to run it on time delay for an entire dive, but I wasn't sure if it was they needed another day or that we were going to start that on this day, on today.
Yeah, I do not know the status of that. Sorry, I
Sure.
do know. So we've been having some issues, and it turns out they were self-inflicted on my part. We originally had we were having some issues with so the the wide field camera array has its own dedicated fiber that comes out of Hercules through Atalanta up through the winch slip ring and into a commercial Cisco network switch in the back of the rack there. And that's the main network, 10 gigabit network path for the cameras, because when you're doing the photogrammetry, there's a whole lot of data happening, and we're trying to download that out of the camera real time. And then on Hercules, there's what we call our Ethernet bottle, and that is connected to Chris's Norbit, and that's a gigabit Ethernet. And Norbit, we clock Norbit around I think 800, so it's taken up almost the full bandwidth.
Huh?
Norbit?
No, 80.
80.
Yeah.
Really?
Yeah.
I thought it was 800.
Yeah, no, I'm not bandwidth greedy like certain camera systems.
Roger. So what we had a cable in between the two, what we call the network bottle for the cameras and the Ethernet bottle on Hercules, and that was kind of like our failover. So in case we had issues with the fiber, we could still take still pictures through Herc's Ethernet. And I thought that I had removed that cable. Well, it turns out I unplugged Norbit and capped Norbit, so we had no Norbit, and we still had that alternate network path in there. So basically what was happening is the cameras are hogs and they were stepping on Norbit. And then when we put them in full resolution mode, they're taking up quite a bit of bandwidth to have the high definition video that you see in front of you. Plus then you start taking photos and downloading them in a timely fashion. So anyways, long story short, we have rectified all that, and our fiber path is good. We're getting a full 10 gigabits a second, and fiber light levels are good, all that technical mumbo jumbo.
Nice.
But I'm not sure where Mike is with the testing.
15 meters altitude.
Yep.
We got
Bottom in sight.
We got 4 beams. Okay, let's put our toys away. Actually, you can leave your toy out. I'll let you do the weight balance. I gotta put my toy away.
What's the importance of the white balance before we start?
So, Amber, do you want to explain white balance, or are you busy?
Sorry, wearing too many hats right now. What question about white balance?
Yep,
Yeah.
just what is it?
We're just trying to calibrate the camera to what a true white is. When we go to depth like this, light bends and there's a lot of blue in our water, right? So we're just trying to make the cameras have a little more calibrated look.
Okay, thanks, Amber.
Yeah.
So you see that white piece of tape on the upper arm?
Yep.
I want to put that right where you have the tip of the jaws right now.
Roger.
Ooh, did I get fresh tape?
You did?
Yay!
I think you did. You didn't get colors though. I did. I put a note on the board and handed it over to our top engineers. That's probably good there.
Okay.
Jayden, if you want to hold that, I will. I'm going to tilt up a bit. And then I'm going to extend the camera so it's a little closer to that. And then I think Amber's going to probably at that
Yeah, I'll
point
need to, probably you'll put the arm up or tilt. Yeah, let's see. Can I zoom in a bit now?
Yeah, absolutely.
Oh, no, it's not new tape.
Fail. Let me come down a little closer to the seabed so we get some background and helps with the white balance, I think.
Looks like it's about time for a wider piece of tape.
Yeah, those ROV technicians are known to be greasy. dirty.
Excuse me. When you're in a good place, I'm gonna go black real quick.
Yeah.
Okay.
Go black. Ooh, look at all those rocks. Can you do me a favor? And I'll do it. I'll do it. You're good. They're going to be using that.
Okay. And now I'm going to go white.
Roger.
Come on. Just take a look. All right. We'll call that good. I might adjust some of the blues here.
Roger.
Separately.
Can you center and zoom in for me so I can figure out?
You wanted to zoom here?
No, I'm talking to Chris.
Okay.
I like my double boxes there. It gives me a good reference. So. Just getting Atlanta set up here. Or more appropriately, Herc in the right place with respect to Atlanta. Something like that. Are you good with the craft there? Can we swing it out of the way? Amber?
Yeah, I'm good.
Okay. Okay, Jane, just swing it to the right and pick it up a little bit so it's out of our view. And you'll want to, when you pick it up like that, put the end effector pointing straight out in front of the vehicle. So it doesn't kiss anything on the porch or the arm itself. And maybe swing to the right a bit more for us. Let's take it out of the picture. Out of the main picture, sorry. Yeah, that's probably good. Now if you pick up the shoulder a little bit.
There's a shout out to Jaden. Well done, Jaden.
Yes, well done. Okay, you can hold on to it there for a minute. And with any luck, you're going to be using it here to get a rock.
All right, to our viewers, we've now reached the bottom, and we are currently at 2,300 meters, almost 2,400.
I have just a couple more tick boxes here I need to do. We take a baseline reading of our hydraulic compensators at this point to make sure we're not going to bleed to death while we're down here. Test all of our auto functions. Nav has probably already done all of their magic over there. You all good?
Yep, just writing down the gauge readings.
Yeah, I'll switch to this one so it's easier. I'll call them if you want. Let me turn off these other lights.
There goes a big shrimp in the corner. Looks like it might be.
So I'll call the res at 4.
Roger.
Mains at 2.5.
Roger.
Motors at 7. Autofocus failure. I don't know why that thing's doing that. 6, 6, and 6, all good. And Atlanta is, you can see it's there all the time, so it looks like it's at 7 as well. 7 and probably 50%.
Copy.
Okay, gauges are good. Autos are good. We're all yours, Saints.
Niskin, please.
Niskin. Niskin before rock?
Or rock before Niskin, doesn't matter.
I'll do the Niskin. Well, let me grab that thing.
Yeah, probably better to get Niskin first before we kick up any dust.
Yeah, agreed. Turn those annoying downlights back on.
You didn't replace your ball, Dan.
No, I was too busy printing honeycomb wall organizers.
What about your softball or wiffle ball or whatever you had?
Gabby prefers the loop, and I have to agree. The problem with too many loops is they get tangled.
Yeah.
These balls are great for the parallel jaws, but they're a little challenging with these snaggle tooth.
Do I get to do the honors?
Yes, please.
Okay. Are you in a good? You ready?
Yeah, I'm ready.
All right. 3, 2, 1. Niskin.
Niskin is engaged.
Yeah.
Or I should say, Niskin is fired. I don't know if you guys saw it, but Niskin number 1 is the bottom right corner of the port rail camera.
Hey, Data, what sample number?
Yep, that is sample 48, first sample of the day.
You want your toy back? Yeah, you do. Or your weapon, depending on how you look at it. Okay.
All right. Medium, large, angular rock, please.
Roger. What did he just say?
It's raining a lot right now.
Oh, roger. Large angular rock. I gotta do one more thing here. Just do a little ballast check. I lagged on that yesterday, and it should be back in our normal Z-bias settings of around my 30% down thrust we use to keep the ROV neutrally, or keep a steady altitude. Angular rock.
These are all pretty angular. It's,
Yeah.
see if that one's loose.
That looks like a beauty. So I'm gonna gently sit down here, and then you can get your weapon out. Okay, ROV is stable on the seabed.
Which rock was it?
I was suggesting this one first, but there's a couple of candidates that would work in this field of view.
Roger.
just to make it extra challenging, Herc is not quite stable. It's balanced on a marble there. Jaden's going for what's affectionately known as the crane grab. You know that game where you put a quarter in, you try and pick up the little prize? I can never get one.
And let me know if you need any zoom.
Don't ruin her to start with.
That's like a big one.
Yeah. So the rock moved.
It moved.
And that is, that's encouraging. So we have a saying, it's all in the grab, as with the board the other day, or the pen we were playing around with. So think about how you want to grab it to get it in the starboard bio box.
So the starboard box.
Yeah. As we put our rocks in the starboard box. So you see how the pitch actuator is all the way at 90 degrees?
Yeah.
So that means instead of a 7-function spatially correspondent arm, you at the moment have a 6-function. So you're limiting your ability. There you go. So more in the sweet spot. So then you're able to use that function to and remember what we talked about with your wrist pitch and yaw being more maneuverable and accurate than your shoulder. And that's looking like a pretty good grab. So when you have it held closed like that, that little button right there will lock the jaws. And when it's illuminated, in theory, you can then relax your finger. But remember, once we get it in the box, to hold the jaw shut before you toggle that button again, otherwise they'll fly all the way open.
Gotcha.
So usually what we do, once we pick up the rock, we show it to the Zeus camera. So you can, yeah, show the trophy to the world and to the scientists. They get some stills of it, and sometimes I'll do a victory roll just for fun, but no, when you do that, you risk dropping it because the weight of it might be funky in the jaws somehow. You guys, y'all happy with that?
Yep, stick in the box.
Roger. So you have two options here, Jaden. One of the things I usually do is I'll put this camera on the craft, and that will let you see the azimuth as you swing around. The other option, we have what we call the sample salvo, which I personally don't typically use a lot, but this shows you the PTZ camera, and then it gives you a bigger picture of the two cameras here, and also puts them out for the rest of the world to see as you come around. So what you just want to do is swing around, keep the end effector high enough to stay out of the mud. And what I'll do is, it's kind of left to right here, so watch that one, and you can actually see the arm go all the way around, and then you'll see it appear in these two cameras. And I'm going to help you out here just a bit. I'm going to come up off the seabed so you don't have to worry about swinging it to the mud. And if you really want to cheat, you can look in Atalanta. It's light years away, but
Yeah, if it was tilted down, I could zoom it in a little bit for you.
I can't tilt it down a little.
All right, zooming a bit just on your Atalanta view.
Jaden's already in the neighborhood, so you can lift up something just a bit. You're just on the
rock. Is it still in the grouper?
yeah.
Okay.
You have me on the edge of my seat there. It's quite challenging this, now you're, doing the armpit grab, but I think if you let it go there, it would go in. But I'll usually push it down in, but either way, yeah, it'll go there. So remember, hold the jaw close. Yeah, beautifully done. That's actually what we want. Now we get to play with it a little. Bash it around. Perfect.
Yay. Congrats. Nice.
Great job.
That is sample 49.
Sample 49.
Oh, that's Jaden's first rock.
You have to get a picture with the rock there.
Yeah, when we get on deck, with Jaden, you have to hold it up like you're, a fish catch.
See
Well
if
done,
I can
Jaden.
find the button to close that box. So now I'll switch back to the, that'll allow you to, so see how the pitch actuator is pointed in towards the arm right there? You want to swing that pitch actuator all the way up and put the jaw like horizontal, facing forward. Then when you tuck it in with the elbow like that, the jaw can't, the end effector can't hit the manipulator. So I'll do that. I'll pull the elbow in, and then I'll move the pitch down last, and then I'm only moving that one function, and I don't inadvertently smack it. But what you can also do is just hit the blue button now. And it'll relax right where it wants to be. Bouncing on my, ooh, hey, did you see that?
What?
It was missing a line for a minute. God, I've never seen that.
It was what?
Like a line just went away.
Yeah.
Wow.
Who knows?
The box still is open?
Yeah, I was, sorry, I got distracted. Thank you. This is our first coral.
Yep, and we could take a tight zoom on that.
We can.
Is that a bamboo coral?
I believe you are correct.
I gotta get my camera back where it's functional. Okay. You're good, Amber, for zoom?
Zooming.
I feel like I'm fidget toy hogging here. I have 3. Which one you want? Sorry, you want to see the coral? I didn't realize I was drifting off there.
Yep.
Here, I'll go wide again.
It's doing important stuff up here. Come on. Okay.
Okay, zooming.
Ooh, I gotta adjust my
Alright.
camera a little.
Yeah, big fleshy bamboo. We have not collected a single bamboo yet, right?
I don't think so. No.
Not yet.
All right, I'd like to go ahead and collect the top 15 centimeters of this.
Roger. Sorry about that. I thought I was muted there while I was gulping the last of my coffee. Is that going to be a snip and slurp, or you want it in the box?
Box probably. Hold on, Steve. Steve is weighing in. Let me see. Make sure this is. Yep, definitely want that one. Yeah, so top 15 centimeters or so, and one of the small starboard boxes.
Rather. That look like 15 there? Too much?
Yep. Nope. That looks great.
Okay. Grip force. Ooh, I forgot to tell you about grip force on the rock. That's why you were on grip force 1. So go
Hard mode.
grip force 1 for corals and grip force 9 for rocks. Sorry, my bad. It's amazing that you were able to.
Jaden's just that good.
Yeah, she is.
Steve has a guess that this is Lepidisis. Bamboo genus.
That was freeze fail. You saw the uncommanded movement there of the manipulator. I thought I had engaged the freeze button, but I did not. You want to slide the box open for me, Jade?
Copy. It was moving really slow. I turned up
the prop.
Yeah.
I had the PRV turned down for the camera, so I don't know where the proportional valve for the actual box is. I don't know why we have that one on a proportional valve. We were meant to put it on the porch. We keep agonizing back and forth there. It's nice to have it slow if you have floaty things in there so it doesn't come flying open. So I always go for D first because it's way easier, but I'm going to go for since the boat is static, go for the harder one here. I forget if these guys are floaty or...
Not as floaty as a black coral, but they're very sticky.